Hi guys, so we're going to start chapter 2, and the title of chapter 2 is Atoms, Molecules, and Ions. And what we will be concentrating on in this chapter are the atomic theory, the structure of the atom, so you're going to know how it's composed of. We're going to learn to distinguish between atomic number, atomic mass, mass number, and isotopes. You're going to learn a little bit more about the periodic table. You're going to learn to distinguish between molecules and ions, and you're going to start learning how to name compounds and chemical formulas. So this is going to be a really important chapter to grasp, just like chapter 1 was as well, but this one is really important as well. Alright, let's get started. Alright, so the first thing that we have to learn is the atomic theory. Now, before I start going into all these words that you see on the screen, I want to talk about Democritus. Okay, so Democritus is this guy right over here, and he was a 5th century BC Greek philosopher. Alright, super smart guy. And he was the one who actually came up with the word atomos, which I believe I mentioned in class. And atomos means something which is uncuttable or indivisible. You know, he thought that atoms were uncuttable and indivisible, the smallest things that you could possibly have. And of course, you know, with time people realized that it was incorrect what he said, but that name stuck. So that's why we call things atoms. That's why we call our, elements atoms. But we know now that that's not true. We know that, as I mentioned in class, there are things smaller than atoms, for example, electrons and protons and neutrons, but let's not get too ahead of ourselves. So the atomic theory is really coined, or was really made famous by John Dalton. All right, and his work really marked the beginning of like the modern chemistry. So he's a really important guy in chemistry. So there's 4 real parts, I would say, to the atomic theory, and it's summarized in these 4 numbers. So number 1, it says that the elements are composed of extremely small particles called atoms, and we know that already. Alright, so number 2, all atoms of a given element are identical. Well, that's easy to remember because, for example, if we have an atom of hydrogen, well, an atom of hydrogen is the same as every other atom of hydrogen. They're exactly the same. That's why they're called hydrogen. And the atom of hydrogen is not the same as the atom of iron. Well, obviously, right? Because they're different atoms. So that's basically what number 2 says, that all atoms of a given element are the same. Duh. Okay, so number 3, compounds are composed of atoms of more than one element, and that's pretty simple as well, right? A compound we kind of talked about in class. So a compound, for example, of water, H2O, all right? So that's composed of 2 atoms of hydrogen and 1 atom of oxygen. Pretty simple. And number 4, chemical reactions involve only the separation, combination, or rearrangement of atoms. And that's a pretty logical statement, right? I mean, so if you have a chemical reaction versus a physical reaction, right? A chemical reaction is something that if you put together, something's going to change, okay? If you bake a cake, for example, you start out with flour, eggs, sugar, whatever else, but once you bake that cake, there's a chemical reaction that has happened between those different compounds, and now it's a different thing. Now it's a cake. Okay? And another example I can give is combustion, right? So you start out with wood, and you have wood, and then you have fire. But once you put those 2 together, you it's a chemical reaction that's happening. You're doing a combustion process. So it's chemically, those 2 compounds have changed into something else. So chemical reaction only involves the separation, the combination, or the rearrangement of atoms. Alright, so section 2.2 talks about the structure of the atom, and on the basis of Dalton's atomic theory, we were able to explain the structure of the atom. Okay, and we're going to learn it in steps. We're going to learn it as we actually discovered the parts of the atom. So first the electron was discovered, and then the proton, and then the neutron. But first we're going to discuss the electron and who was responsible for figuring out that there were electrons. All right, let's get started. All right, so the electron is the first thing we're going to talk about, and I do want to mention that back in the 1890s, so a long time ago, right? Back in the 1890s, a lot of scientists were caught up with the study of radiation. Okay, now radiation is defined as the emission and transmission of energy through space in the form of waves. Now, the information that we got from the research of radiation really helped a lot of scientists understand the atomic structure. One of the devices that they used to learn about that phenomena was called the cathode ray tube, which I'm showing you right here. Now, the cathode ray tube, you may not know, but it is the forerunner of the television. Of course, now we have plasma and LCD screens, but the first television was basically this behind your television, and that's how you would see pictures. But anyway, that's neither here nor there. All right, so what you have here is it's a glass tube, and the tube, you basically suck out most of the air from the tube, right? So you evacuate the air. And there's two metal plates that are connected to a high voltage source right here. So you have the cathode, which is the negatively charged plate, and you have an anode, which is the positively charged plate. So now when you turn the high voltage on, the cathode emits this invisible ray that we would never see, right? But well, what happened is that these really smart scientists said, why don't we go ahead and put this fluorescent screen on the other end of the tube and see what happens? Well, when they did that and they turned the high voltage on, the cathode emitted the invisible ray, and of course, it was attracted to the anode and went through and hit the fluorescent screen. And they noticed little dots. You know, when the voltage was on, they noticed that the fluorescent screen would get like black dots. So that was, of course, I mean, no one knew what that was at that time. So it was really exciting research. So, of course, they kept playing around with it, and they wanted to figure out, okay, so what is the charge on this invisible ray that I can't see, but apparently something's hitting the screen. So does it have a charge? So what they did is they decided to put two electrically charged plates and a magnet. Those were separate experiments. Okay, so they added these electrically charged plates and just put it close to the tube to see if anything would happen. So what happened was that they basically turned on a positive field, right, and a positive electric field. And when they did that, they noticed that the little dots changed positions, right? So it didn't hit. So with no with no electric field on, the dots would hit point B. Didn't mention that before, but they would hit point B. Now, when you turn the positive field on, a positive electric field on, they noticed that the dots started hitting point C. So obviously, I mean, what is that? What do you conclude from that? If you turn on a positive electric field and now the actual invisible ray or the dots get closer to the positive field, that means what? So that's a good thing to think about, because if you know anything about the electron, it's negatively charged, right? So if you have a positive field and you have a negative charge, is it going to be attracted or is it going to be detracted from each other? So obviously they're going to attract. Opposite charges attract. So that's why when you turned on the positive electric field, that dot would get closer and hit point C. So they figured out these experiments were done by J.J. Thomson, okay? And he used the cathode ray tube and his knowledge of, electromagnetic theory to determine the ratio of electric charge to the mass of an individual electron. All right, and the number that he came up with was negative 1.76 times 10 to the 8th coulombs per gram. Okay, now coulomb is the unit of electric charge, right? The SI unit of electric charge, but that's not that important. What you guys need to know is that J.J. Thomson was really the guy that came up with the charge to mass ratio of an electron. So he was kind of the first guy. And after J.J. Thomson came this guy R.A. Millikan. Now, he was really successful in measuring the charge of an electron. Now, he did this with super great precision, all right? So, and what happened was that his work proved that the charge on each electron was exactly the same. Awesome, because that's helpful for us to know. But through his experiment, which is called the oil drop experiment, he was able to find that the electric charge was negative 1.60 times 10 to the negative 19th, and with that, using math, he was able to find the mass of an electron. So Millikan is really known for being able to find the mass and the charge independently of an electron. Okay? So I urge you to look at the animation that I have posted under chapter 2 called Millikan's oil drop experiment, so you could see how that experiment worked. It was really exciting stuff to find, being able to suspend an oil droplet in midair, with positive or negative electric fields. Now, you will be responsible for knowing the accomplishments of who did what. For example, you need to know J.J. Thomson and what he did. You need to know what Millikan was responsible for, and pretty much be familiar with the experiment. For example, Millikan's oil drop experiment. There are other people that you should read up on, such as Rutherford and Chadwick. Rutherford was known for his experimental design of measuring the scattering of alpha particles by a piece of gold foil. So by the early 1900s, two features became apparently clear about the electron. Number one, they contained electrons, and that was because of J.J. Thomson and Millikan that we learned about. And number two, they were electrically neutral. All right, but for the atom to be electrically neutral, the atom must contain an equal number of positive and negative charges, right? So Thomson, J.J. Thomson, the guy who first discovered the electron, proposed that an atom could be thought of as a uniform positive sphere, all right, of matter in which the electrons were kind of like placed into this sphere, right, embedded into this sphere, and he called it the plum pudding model, because it was kind of like raisins embedded into a cake, like a plum pudding cake. So that's what he called it, and that was accepted for a number of years until this guy Rutherford, which I told you needed to read up on, figured out that this model was incorrect. And you need to be able to recognize that Rutherford was the one that did the alpha scattering gold foil experiment. So after Rutherford figured out that the nucleus basically was a dense central core within the atom that held the protons, there was one last problem that scientists needed to figure out. It was known that hydrogen, right, the simplest atom, contained only one proton, and that the helium atom, which is the one right next to hydrogen, contained two protons. Therefore, just by logic, the ratio of the mass of the helium atom, which is one proton, should be half of the mass of a helium atom, which is two protons. But when they measured the mass of helium and hydrogen, it was not 2 to 1. It actually was 4 to 1. So at that time, obviously scientists didn't know, but they kind of guessed, right, that there must be another type of subatomic particle in the nucleus. And the proof was provided by an English physicist called Chadwick. So Chadwick is known for in discovering the neutron. Now a neutron is in the nucleus with the protons, and they are exactly like the name signifies. They're neutral, all right? And they weigh more or less the same as the mass of a proton. And that's why when you measure the mass of hydrogen and then you measure the mass of helium, helium has 2 neutrons in its nucleus, making the mass of helium 4 to 1. So the mystery of the mass ratio can now be explained. So in the helium nucleus, there are 2 protons and 2 neutrons, but in the hydrogen nucleus, there's only 1 proton and no neutrons, and therefore that's why the ratio is 4 to 1. Table 2.1 summarizes the mass and the charge of the three subatomic particles that you need to be responsible for: the electron, the proton, and the neutron. Next video module will discuss atomic number, mass number, and isotopes, and some other things. See you then!